Imagine you're at a restaurant and the host assigns you to a table, but when you get there, the table is empty and the server is nowhere to be found. This is similar to what happens when your application is not properly configured to handle requests. In Kubernetes, Liveness and Readiness probes act like the restaurant host, ensuring that your application is always available and healthy. In this tutorial, we'll explore how to configure these probes to keep your services running smoothly. We'll start by understanding what Liveness and Readiness probes are and why they're essential for your application's availability. Liveness probes are like the restaurant host checking if the server is available to take your order. They periodically check if your application is running and responding correctly. Readiness probes, on the other hand, are like the host checking if the table is ready for you to be seated. They check if your application is ready to receive traffic. Both types of probes are crucial for ensuring your application is always available and healthy. Liveness probes help prevent your application from crashing or becoming unresponsive, while Readiness probes help prevent your application from receiving traffic when it's not ready. By using both types of probes, you can ensure that your application is always available and providing the best possible experience for your users. For example, if your application is a web server, a Liveness probe might check if the server is responding to requests, while a Readiness probe might check if the server has finished initializing and is ready to handle requests. Let's take a look at the architecture diagram for Kubernetes Liveness and Readiness probes. The diagram shows a pod with a container running your application. The Liveness probe is configured to check the application's health by sending a request to the container. If the probe fails, the container is restarted. The Readiness probe is configured to check if the application is ready to receive traffic by sending a request to the container. If the probe fails, the container is not sent traffic. The diagram also shows the Kubernetes control plane, which manages the pods and containers. The control plane receives the results of the probes and takes action accordingly. To follow along with this tutorial, you'll need to have a Kubernetes cluster set up and have the kubectl command line tool installed. You'll also need to have a basic understanding of Kubernetes concepts such as pods and containers. Don't worry if you're new to Kubernetes, we'll explain everything in detail. If you don't have a Kubernetes cluster set up, you can use a tool like Minikube to create a local cluster. Now, let's compare Liveness and Readiness probes. Liveness probes are used to detect if an application is running and responding correctly, while Readiness probes are used to detect if an application is ready to receive traffic. You can use both types of probes together to ensure your application is always available and healthy. For example, you might use a Liveness probe to check if a web server is responding to requests, and a Readiness probe to check if the server has finished initializing and is ready to handle requests. To configure a Liveness probe, you'll need to create a YAML file that defines the probe. The probe will periodically send a request to your application to check if it's running and responding correctly. If the probe fails, the container will be restarted. For example, you might configure a Liveness probe to check if a web server is responding to requests by sending a GET request to the server's health endpoint. To configure a Readiness probe, you'll need to create a YAML file that defines the probe. The probe will periodically send a request to your application to check if it's ready to receive traffic. If the probe fails, the container will not be sent traffic. For example, you might configure a Readiness probe to check if a web server has finished initializing and is ready to handle requests by sending a GET request to the server's Readiness endpoint. Here's a flowchart that shows how Liveness and Readiness probes work together. The flowchart starts with the probe sending a request to your application. If the probe succeeds, the application is considered healthy and the probe will continue to monitor it. If the probe fails, the container will be restarted or not sent traffic, depending on the type of probe. The flowchart also shows how the Kubernetes control plane manages the probes and takes action based on the results. To verify that your Liveness and Readiness probes are working correctly, you can check the Kubernetes console. You can see the status of your pods and containers, as well as the results of the probes. If a probe fails, you'll see an error message indicating what went wrong. You can also use the kubectl command line tool to check the status of your pods and containers. One common issue with liveness and readiness probes is that they can fail if the probe is not configured correctly. For example, if the probe is sending a request to the wrong endpoint, it will fail and the container will be restarted or not send traffic. To fix this issue, you'll need to check the probe configuration and make sure it's correct. Another common issue is that the probe can fail if the application is not responding correctly. For example, if the application is taking too long to respond, the probe will fail and the container will be restarted or not send traffic. To fix this issue, you'll need to check the application code and make sure it's responding correctly. In this tutorial, we learned about Kubernetes liveness and readiness probes. We learned how to configure probes to ensure our applications are always available and healthy. We also learned how to troubleshoot common issues with probes. By using liveness and readiness probes, you can ensure that your applications are always providing the best possible experience for your users. Remember to always configure probes correctly and to troubleshoot issues promptly. Subscribe for daily in-depth DevOps tutorials explained in simple terms.